From an observational standpoint, we're at a sweet spot where we can see many different aspects of the changing ice cover. And so the problems are then moving toward understanding what we see changing. It is pretty clear that we're going to understand what the ice is doing. I think that observational glaciology in terms of remote sensing is a very data-rich field now compared to 1972 when you had a few images. So we are beginning to get a historical record of the speeds of glaciers. And so we can watch how rapidly that surface is lowering as things speed up, or where it's thickening, and where the surface is actually coming up, where ice is actually thickening on land. With this record, we can go in and look at the speeds of ice flow over decades and how it's been changing. The reaction I get from other people that study glaciers is that I watch these videos too fast. I like to see the fluid nature of the ice. It lets you see the ice on the land as sort of this very active participant in what's going on. One of the places that I like to look at in this particular video of Hubbard is if you look just to the upper left off the 5 kilometer scale bar, you can watch the edge of the glacier just spread across the river bed that's coming out of the glacier that's adjacent to it. And it just moves, trees, it moves all sorts of material every single year, just advancing. So this video that shows the Walsh Glacier on the top and the Logan Glacier on the bottom, these are huge glaciers. They're the order of 4 kilometers wide or so. What we see as we loop through it is that the flow in both of these sits there for years, and then it will undergo a pulse of faster motion and then sit there again. What strikes me about this image of the Malaspina is that you can really see its nature, which is that it's a large puddle of ice. You've got huge glaciers that are flowing down out of a really high mountain range. And these big glaciers reach the coastal plain, and the ice, like you'd taken a bottle of syrup and just dumped it in the middle of a plate. The Malaspina is sort of that big pile of syrup. The other thing that you see is that the ice coming in will head either to the left or the right of center for a while, and it will string out those moraines so that they get bent into these loop shapes. And it wasn't until I saw this video that I felt like I had a good understanding of just what was producing these amazing loops in the moraines. In compiling this Landsat record from Landsat 1 in 1972 up through today, I've gone through year by year, and I've tried to pick out the latest melt season image I can. So the white snow of winter is gone, and you can see the detail and the flow stripes and the crevasses in the ice, and build annual mosaics that give us an image of all of the ice in Alaska and the Yukon. And when those are all lined up, all 48 of them are lined up and played as a movie, we can see the behavior of the ice over nearly half a century. Having such a long record allows us to discern long-term trends and separate them from the kind of behavior you might get with a couple warm or a couple cold years. To have a persistent observational capability that's been in place ever since the first Landsat was launched, it